Okay, in this video I would like to start processing some of this data, creating graphs and trend lines and getting formulas. But before we do that, I'll take a look at this data. And you can see there's some strange things here. An aperture photometry tool does a good job, however it's not perfect. And it can identify things as stars that aren't stars. And that's some of what you see here. For example, here's a negative signal-to-noise ratio. And then no magnitude associated with that. Also, some of these FWHMs are way out of line. So what I suggest doing is cleaning this up a little bit. And what I do to start is to create a filter. Click on the little drop down here, and you can see the different values here sorted by size. And you can see that most of them are between 2 and 4. There's some big ones, there's some definite outliers in here. And I happen to know that for my system, the typical star profile has a FWHM of about 3 arc seconds. And I'm imaging at about 1 arc second per pixel, so that works out nicely to be about 3 pixels. So what I'm going to do is create a number filter that's going to filter out all of the ones except those between 2 and 4 pixels. Okay. Next thing I want to do is filter out some of the signal-to-noise ratios. Since we are concerned mostly with imaging faint objects, we really want to know how faint we can go. We're concerned with the smaller signal-to-noise ratios. If you look at these, there are some strange ones in there, and then most of them are below 100. In fact, there's a big drop here between 104 and 44. So what I'm going to do is create a filter. Filters out all those between 1 and 100. Okay, that cleans things up very nicely, and I think we're ready to go. So let's save that. Now, you can plot all of the data. Let me turn this filter off, which I created. This is going to show all of the images here. We highlight this, signal-to-noise ratio and magnitude. Now we're going to do a insert scatter. Here is all of the data for our 10-second series. And you can come in here and do a trend line, a logarithmic trend line, show the equation, correlation. And you can see that the correlation is about 0.92, which isn't bad. It's a nice distribution here. It gets a little spread out as you start getting to fainter objects, lower signal-to-noise ratios. And of course, this is the area that we're really interested in down in here. And what we want to do is we want to create one of these graphs for each stacked image that we have. So let me delete this. And back in Aperture Photometry Tool, I suggested processing all of your images and saving them into one big CSV file. And that's what we have here. And then we can go in and, using this filter, select these different images one at a time. So I'm going to turn them all off, and I'm just going to grab the first one here. Okay. Highlight this row and this row. Column. Insert scatter chart. Okay. I'll move it over here. Come up here to layout, trend line, logarithmic. I want to display the equation and the correlation. And here you can see the correlation is much better. Very good correlation. And this is the equation that we're interested in. So here we have the graph and the formula. And what I'm going to do is move this to its own sheet. Okay. Now, what I want to do is copy this equation. I'm going to stick it in Notepad. Come back here. Come back to the data, and we're going to process the second image. So turn that one off. Come down here to there. That's the second one. Highlight the columns. Here is the second equation. Highlight that. Back to the data. Do the next one. Turn that off. I believe it's this one here. Yes, that's 5. That's 60 seconds. Highlight the columns. Come back to this chart. So we're not really creating a new chart for each one. We're using this one chart and just updating the columns that it's using. Highlight that. Let's actually get the whole thing. Copy and paste that equation in here. So you start building up this list of equations, these logarithmic equations for each image that you've taken. Here's one for 20 seconds. This is the one for 40 seconds. This is the one for 60 seconds. We'll do one more. Process the next one. I believe it's this one here. 80 seconds. Okay. Make sure you got the columns highlighted. And here's the equation. Control C, Control V. So you go through all of your stacked images and you come up with this list, these list of equations. You should have at least 10 of these. In my case, in this example, I actually did, I believe, 15 of them. So that's step one in getting the graphs and equations created. Next is going to be where we create a table using these equations to create a table of exposure time versus signal to noise ratio. Here we've been creating a tables of magnitudes to signal to noise ratio. The next step is to create a table in graphs of exposure time to magnitudes. So I'm going to stop this video here and do that in the next video. Thank you for watching.